In this section, we are going to see the construction of a ceiling fan, the dismantling procedure of a ceiling fan, and the general faults that can occur in them. The function of a ceiling fan is to circulate air for cooling purposes. The capacity of a fan is usually expressed by its sweep and wattage. The visual parts of a ceiling fan are rubber grommet, bolt and nut, cotter pins, shackle, top canopy, down rod, bottom canopy, bottom bolt and nut, capacitor, fan blades. The top cover is made of die-cast aluminium and the fan blades are also made of aluminium. Ceiling fans are available with either 3 or 4 blades. The rotor and the blades are freely rotated with the help of ball bearings or bush bearings which are housed in the top and bottom cover of the fan. The blades are fixed on the top cover using fixing screws. The entire unit is then hung from the ceiling with a suitable pipe threaded on both sides and tightened with suitable check nut and a cotter pin to lock it in its position. The auxiliary winding is connected in series with a capacitor and main winding is connected across the power supply. The value of the capacitor varies from 2 MFD to 5 MFD according to the sweep of the fan. Externally, a regulator is used to vary the speed of the fan by varying the applied voltage. Normally, each fan has its own set of blades which are factory balanced. Carelessness in handling will cause the blades to wobble, which will end up in noisy operation and also shorten the life of the fan. The faults that generally arise in a ceiling fan are noise, low speed, jamming of the rotor, and not rotating. The cause of the noise could be slack canopy, a worn-out grommet, loose or missing screws, a slack capacitor housing, dirty or worn-out bearing, misalignment of blades. A humming noise might arise due to non-uniform air gap owing to the displacement of the rotor. Low speed might be due to a defective capacitor and low voltage. If the voltage on checking is found to be normal, remove and test the capacitor. A leaky capacitor cannot be tested easily while connecting in the circuit. To check whether a capacitor is open, connect it to the test lamp in series. If the lamp glows dimly, it means the capacitor is okay. If the test lamp does not glow, then the capacitor is open. If found defective, replace the capacitor with another one of the same capacity. Jamming of the rotor might once again be due to a defective capacitor. Overheating of the motor might be due to partial short circuit in winding. A short capacitor might also heat up the fan. A fan might not start if the voltage is low or the winding is open or the condenser is open or short. Even if the resistor in the regulator gets open, the fan will not rotate. The fan might wobble if the screws which attach the blade flanges to the motor hub are loose. Also check for the tightness of the bolt and nut in the shackle and hanger clamp. Check the grommet for damage. Replace if necessary. Next, let's see how a ceiling fan is to be dismantled. Make arrangements to reach the ceiling fan through the stable means of elevation. Safety of the worker is of utmost importance. Disconnect the wires from the ceiling rows. Lower the top canopy. Bring down the fan after removing the split pin, the cotter, and the rubber grommet from the shackle and clamp. Remove the fan blades and refit the screws along with the spring washers in the body of the fan itself so that you may have easy access to them when refitting. Separate the down rod along with the canopies from the condenser house. Remove the split pin and set screw. Next, remove the condenser from the housing. Mark and unscrew the cover fixing screws and separate the bottom cover and the rotor. Pull out the rotor and the stator from the top cover. Inspect all the removed parts. Replace the defective parts and reassemble the dismantled parts in the reverse order. On inspection, if any trace of moisture is found on the motor, the fan needs to be tested for its insulation. If the insulation resistance is less than 1 megohm, then the fan body needs to be dried by using a 500-watt bulb or in an oven. In this section, we saw the construction of a ceiling fan, the general problems that could occur, and the procedure for dismantling the fan.